Let's start chapter number 9, Reversible Reactions and Equilibrium. Okay, here our key learning objectives are understand reversible chemical reactions, explore how conditions affect reaction directions, examine industrial processes like Haber's and contact processes, study equilibrium concept in chemical systems. First, we have reversible reactions. Fundamental concepts are definition, chemical reactions that can proceed in both forward and reverse directions, represented by double arrow like this in a chemical reaction. Equilibrium characteristics occurs in a closed system. Forward and reverse reaction rates become equal. Dynamic state where concentration remain constant. Let's talk about ammonia production, the Haber process. Historical context developed by Fritz Haber in early 20th century, Nobel Prize in Chemistry in 1918 addressed global food production challenges. Essential process conditions, reactant ratio 1:3 for nitrogen and hydrogen, temperature at 450 degrees centigrade, optimum compromise, pressure is 20,000 kPa, 200 atmospheres, catalyst finely divided iron. Industrial significance, it produces approximately 175 million tons of ammonia annually, supports approximately 50% of global food production. Now, ammonia utilization, usage, distribution, application, it is used 75% in fertilizers, 10% in nitric acid, 10% in others, 5% in nylon. Now let's talk about contact process. It is sulfuric acid production. The process conditions are temperature at 450 degrees centigrade, catalyst vanadium 5 oxide, and the pressure is 200 kPa. Raw materials and the sources are sulfur, mined globally, extracted from fossil fuel desulfurization, obtained by burning sulfur and roasting sulfide ores. Now let's talk about equilibrium principle, Le Chatelier's principle. Factors affecting the equilibrium. Number 1, temperature, exothermic reaction favored by lower temperature, endothermic reaction favored by higher temperatures. Second is pressure, increasing pressure shifts equilibrium toward fewer gas molecules. Next is concentration, changes in reactant product concentration alter equilibrium position. Now let's talk about environmental consideration, Haber process challenges. High energy consumption, significant carbon footprint. Current research focuses on green ammonia production. Sustainable development strategies. Hydrogen from water electrolysis, renewable energy sources, more efficient catalysts such as ruthenium. Key takeaways here is industrial processes require careful, controlled conditions. Reversible reactions are crucial in chemical manufacturing. Equilibrium is a dynamic, balanced state. Technological advancement aim to make processes more sustainable. Now let's talk about reversible reactions and equilibrium. Our key concepts. Fundamental understanding here is reversible reactions are chemical processes that are produced proceed in both forward and reverse directions. It indicated by the symbol in chemical reaction. The symbol is this reversible reaction symbol, like one arrow like this, another arrow like this. Occurs in closed system where reactions can reach equilibrium. Equilibrium characteristics. Equilibrium is what state where forward and reverse reaction rates are equal. Concentration of reactant and products remain constant. Factors affecting equilibrium: temperature, pressure, concentration, and catalyst presence. Now, chemical tests and observations. Water detection methods, hydrated salt color changes, cobalt chloride test, melting and boiling point analysis. Some industrial processes, such as Haber process, where we produce ammonia, our equation will be this: ammonia plus hydrogen gives us ammonia. Key consideration, as we discussed earlier as well: temperature 450, pressure 20,000 pascal, catalyst iron, raw material will be hydrogen and nitrogen. In contact process, sulfur dioxide with oxygen gives you 2SO3, the production of sulfuric acid. Key conditions: temperature 450, catalyst is vanadium 5 oxide, pressure is 200,000 K pascal, raw material is sulfur dioxide and oxygen. Fertilizers now. Let's talk about fertilizers. Type of fertilizers are NPK fertilizers, means they provide nitrogen, phosphorus, potassium. Ammonium, salt, and nitrates are commonly used. Fertilizers composition: we have nitrogen. Purpose in the plant growth is providing protein and chlorophyll production. Phosphorus is for root and flower development. Potassium is for overall plant health. Let's talk about environmental consideration. Potential pollution risk can be excessive fertilizers use, inappropriate application methods. Industrial optimization strategies. First is maximizing product yield. How? Increase product output, reduce waste, minimize energy consumption, find optimal reaction conditions. Some reversible reactions are having dynamic chemical equilibrium. What are the key characteristics of equilibrium? Dynamic process means continuous transformation between reactants and products. Closed system, it occurs in forward and reverse reactions happen simultaneously. Rates of forward and reverse reactions are equal. Concentration of reactant and product remain constant. Some positions: left hand side favors reactant, right hand side favors products. Determined by relative concentration of reactant and products. Analogies for understanding equilibrium: escalator analogy, persons running up and moving down accelerator appears stationary. Swimming upstream, fish swimming against current appears motionless. Now let's talk about Lee Chatellier's principle fundamental rule. When conditions of a system is dynamic equilibrium are changed, the system moves to oppose that change. Now some factors which is affecting equilibrium positions: temperature, which shifts the reaction toward endothermic or endothermic direction. Pressure shifts towards fewer gas molecules. Concentration shifts to reduce increased concentration of specific substances. Catalyst, it speeds up equilibrium but does not change position. Let's talk about temperature effects. So in exothermic reaction, increasing temperature shifts the equilibrium left, favors reverse endothermic reactions. Endothermic reactions, increasing temperature shifts equilibrium right, favors forward exothermic reactions. Pressure effect only affect reactions involving gases. Increased pressure means shifts equilibrium towards side with fewer gas molecules. Decreased pressure shifts equilibrium towards side with more gas molecules. Concentration effects: adding, removing reactant or product changes equilibrium position. System respond to restore original concentration balance. Example: ester formation. Removing water shifts equilibrium right, demonstrates how concentration changes impact reaction. Let's talk about industrial application of Haber process, which is ammonia synthesis. The reaction is N2 plus 3H2 gives 2NH3, critical for fertilizer production, optimized through high pressure, control temperature, and balancing reaction conditions. Similarly, contact process, the reaction is 2SO2 plus O2 gives 2SO3, demonstrate equilibrium principle in industrial chemistry. So our key takeaways: equilibrium is dynamic balance state. Conditions can be manipulated such as temperature, pressure, and we need to understand equilibrium crucially for industrial and chemical processes. With this we have finished our this chapter and see you in our next